Uncle Pythagoras welcomes you once more. This is Theorem 9. Theorem 9 says that the angle between a tangent to a circle and a chord drawn from the point of contact is equal to an angle in the alternative segment. This is your 10 chord theorem. They like this more than any theorem that we have done. This is the most favorite. In your exam, maybe they can want you to prove it, but you must be able to prove it. And you use this theorem more often to find the angle and the unknown angles or the required angles. Right, you are given tangent A, B, C. You are required to prove that CBD is equal to BED. Now, let's draw this tangent. Let's draw this sketch to see what we are talking about. Here is our circle. Center O. We have angle. We have point F in the circumference. You have E. You have B. And D. This is all you have. Then you have A, B, and C as your tangent. Here is your tangent at point B. Now, before we can prove anything, you have to tell the marker that I am going to construction. You are going to join B and F. Draw B, O, F, and you must join. You join B, E, F, F, B, O, F, and you must join E, F. Join E, F. You are going to join E, F. Now, let's just join them together. Let me just move this little bit further E here. Right? We are going to join B, O, F. There is your BOF and join EF. This is EF. We are joining EF. Now, from the original, you are given triangle BEF, BED. Now, this is what you have originally. And this is what you are given. E1 and E2, E1 and E2, B1 and B2, B1 and B2. Now, we are required to prove that, where is our required to prove? CBD. CBD. That means this triangle, this angle. We are required to prove that this angle, the angle between the chord and the tangent, is equal to the angle in the alternative segment, which is BED. BED. This one. Right, we are required to prove that. Somehow we must know that, we must find that this is 2, sorry, this is not B1, our B1 is here. This is your B1, this is your B2. Yes, this is B1, B2, let's check here, E1, E2, yeah, everything is in place. Right, we come to prove that theorem. We start by saying, if you can check, this is a diameter. The angle subtended by a diameter at the circumference is 90 degrees. You see, E1 and E2, there must be 90 degrees. What is the reason for that? Angles at the circumference. Angle at the circumference, or you can say angle or angle subtended by a diameter BOF. You see, this diameter BOF, this is your center O, this is your O here. You see, BOF, it subtend which angle? Angle E1 and angle E2, or angle FEB. Right. Also, we can say that B1 plus B2 is equal to 90 degrees. Let's check this. B1 and B2 is 90 degrees. What is that? The radius. We proved that in theorem 7. The radius is perpendicular to the tangent. Radius perpendicular to tangent. Since we know that both equals to 90, we can say that E1 plus E2 is equal to B1 plus B2. Here we must put the subscript 2, B2. The reason for that, both angles equals to 90 degrees. If they are both equals to 90 degrees, there is a condition that says but, and then E1 is equals to angle B1. You remember it was theorem 4. If I'm not mistaken, yes, it was theorem 4, the butterfly theorem. That this angle is equals to this angle if we have A, B, C, D. You see that? A, B, C, D. So this BC, if this is a circle, then this is a chord. Angle A is equals to angle D because they are both subtended by the same arc or the same chord BC. This is chord BC, this is arc BC. You see, this condition comes and applied here. You see this E1 and B1. Here is your E1, and B1. It's that. You see, they are all subtended by FG. Therefore, you say subtended by arc FG. Then you come to the statement here. Where you see E1, you put B1. You see E1, I put B1 plus E2 is equals to B1 plus B2. B1 cancels, B1, you are left with E2 is equals to B2. Let's check what is your E2. E2 is here, B2 is here. Therefore, CBD is equal to BED. Proved. Right, I would love to thank you very much. The next problem that we are going to do is to check the problem that want us to apply these theorems. Uncle Pythagoras, thank you very much. Thank you very much.